The dreaded reboot. Did it take me 3 minutes? That's not too bad, actually. You there?
Nope.
Yeah.
Yeah.
No, with the old Windows operating system, it used to take me 10 minutes. It was awful when I had to reboot in the middle of a session. It's not so bad with Windows 10. It reboots pretty fast. Okay, let's see. Read to me where we left. Hold on. Hold on a second. Just a second. Tell me I did that. I did do it. Hold on, I gotta open it. You know, it worked. I tested it. Before I called you with the new meeting ID number. Oh, man, I get the way they cover up the thing. Come on, really? Minimize that so I can. Oh, excuse me. All right. Now, tell me where we left off.
We had 5 parenthesis t plus 1 close parenthesis over t plus h plus 1 in parentheses. Yeah. And you have 5 times t plus h plus 1 close parentheses over t plus h plus 1 times t plus 1.
Yeah, it's easier to recreate than I thought. Once you do enough of these. And all of that's over h. So the only thing we can do now that we have a common denominator is to operate on the numerator. Well, we can't operate on the numerator until we've distributed it. So what's the new top left of the numerator? Distribute the 5.
5t plus 5.
Okay. Distribute this 5.
5t plus 5.
5t minus 5h. You got to take that negative sign and apply it to everything in the parentheses.
Minus 5.
Now simplify that.
5 times t plus 1 minus.
Hold on, where are you getting the plus 1?
Because it's got the 5t plus 5.
Correct. You're not factoring. We just had it factored and we had to multiply it together. So don't ever go backwards on yourself. In other words, factoring that 5 out would just take us back to the previous step. We distributed the 5 so that we could combine everything. Notice that I got a plus 5t and a minus 5t. Notice that I got a plus 5 and a minus 5. Remember in calculus that every term that didn't have h in it went away. That's the way these things work out. No matter how complicated this function is, p of t, by the time I've simplified it, the new numerator will not have any term in it that does not have an h. That's just the way this thing works. When you take p of t plus h minus p of t, you lose all of the terms that don't have h. So now this is what I got. Let me change to a different color. I've got minus 5h in the numerator of my numerator, whose denominator is t plus h plus 1 times t plus 1. Still leave it unfactored. I mean factored. There's no reason to factor that. It's all over h. Now, you see the beautiful thing that happens is that every term that did not have h disappeared. And that's now going to allow me to cancel this h with this h in the bottom. So where I started with a problem that was basically 0 over 0, it's no longer 0 over 0 after I cancel the h's. Now you might say, well, how do I cancel those h's? Well, let's put a 1 under that h, and you divide by a fraction by flipping it and multiplying it. Well, when I flip and multiply, the h's get canceled. So here's what I'm finally left with. A minus 5 in the numerator, all over t plus h plus 1 times t plus 1. And that is my answer to this problem. Now, had they said, what is the limit of that as h goes to 0? I just plug in h of 0 and you end up with minus 5 over t plus 1 squared. So they didn't take it to its ultimate calculus meaning. So I guess you could call this a little bit of precalculus, but this is the hard part of the calculus, right? In other words, it wasn't coming up with p of t plus h or p of t that was hard. It was the algebra that was hard. The algebra is what's always hard on these limit definition of first derivative problems. Always the algebra that's the hard stuff, not the calculus. So this was every bit as hard as any calculus problem where you had to use the limit definition to solve it. Okay, have you read it?
It says, what is the radius of the spill when it was first observed, but we don't know t?
Actually, you do. T represents the number of minutes since the spill was first observed. What is T when it's first observed?
0.
Okay. So what they're saying is, what is R of 0? Well, what is R of 0?
1 or 4 plus the cubed root of 1. So 5.
What goes in? Nope. What goes in that radical? You said 0. You didn't say 1.
Yeah, 0 over 2 is 1.
No, it isn't.
It's 0.
Okay. What's the cube root of 0?
0.
Okay.
So 4.
Okay. Now, express the area of this oil spill as a function of time. Well, what's the area of the oil spill? It's the area of a circle.
So it'd be pi r squared.
And r in this case is 4 plus the cube root of t over 2, all of that squared. So when they say express the area as a function of time, I just did it. There is only one variable on the right side of that equation, and it's t. So I can write a of t. The area as a function of time is equal to that. And I don't need to do anything more with it. And I certainly don't need to square that. I have written it as a function of time. In fact, I wrote it very similar to the way they wrote radius as a function of time. Notice that if radius is a function only of time, and if area is a function only of radius, then area can be expressed as a function only of time. It's a little bit like a related rate problem. You know the rate that the radius is increasing. You want to know what the rate of the area is. So how do I do the next part C? How do I solve for the exact time when the area is 81 pi square inches?
You substitute 81 pi for the area.
And for the moment, we won't worry about units. We'll just assume that they're not trying to trick us here, you know, by giving us one unit in square inches and the other in feet or something like that. In real life, you really, well, even in math, you have to kind of allow for them to change up the units. You have to be leery of it. But it looks like everything is in inches and minutes here. In other words, the radius is measured in inches, the area is measured in square inches. How do I solve that? What's the first step?
Divide by pi to both sides.
Correct. That gets rid of the pi. In other words, it turns the pi into 1. Okay, what's the next step?
Take the square root of both sides.
Okay, now that's really plus or minus 9 equals this. And most likely, the minus will not be an answer because you can't have negative times, right? But we don't know yet whether we're going to get a negative time. Probably will, because at some point we're going to have to cube both sides. And when we cube both sides, this negative 9 is going to go to minus 700 and something. So there's no way time is going to be minus anything. So let's forget the negative sign, even though it wouldn't normally be proper to forget it at this point. It's just that it's pretty easy to see that if I leave that plus or minus 9 in there, I'm going to have a t that's negative by the time I get done. I'll have a positive and a negative, and I'll just choose the positive and throw away the negative. So let's do that. Let's leave it both in there. Now what?
We'll do subtract 4 to both sides.
Okay, so I get 5 equals this, or minus 13 equals 1. In other words, at this point, both of those are still possible solutions, especially if we're 1,000 years into the future and time can be negative. But at present time, time can only be positive. So how do I solve the first equation?
You cube both sides.
So 5 cubed is 125. That becomes t over 2. What's t equal to? Solve that.
250. Yeah, 250.
And that is in minutes. They've been very clear that t represents the number of minutes as long as the radius and the area is in inches or square inches. Okay, so that's one answer. Notice that if I try to solve for a second answer, I do have to cube both sides, which means t is going to be minus some enormous number, 13 cubed, but it's still going to be minus.
Minus 4,394.
13 cubed times 2. That's a giant negative number. Time can't be negative. We throw that solution out. Our only solution is 250 minutes. And that is going to be the exact time. And you might realize how practical that could be in life. Let's say you had a city and there was a giant oil spill and you wanted to know when it was going to reach the edge of the city. You know, the oil spill is maybe 5 miles away. Well, if it reaches 81 pi square feet, it's going to hit the city. So it'd be nice to know that t is 250 minutes. That gives you 4 hours to evacuate the city before the oil spill hits it, or whatever else might be in its way. Wouldn't have to be a city. It could be a pristine lake or a wildlife sanctuary or something that you wouldn't want get hit by an oil spill. Finally, let's do the D. Find and give a practical interpretation of R16 minus R of 2. First of all, tell me what R of 16 means in words.
The radius is 16 inches.
No, the radius when time is 16 minutes. In other words, that means that whatever's in the parentheses is t, it's time. What does R of 2 mean?
R of 2 minutes.
It's the radius when the time is 2 minutes. So what is R of 16 minus R of 2? The change in the radius between 2 minutes and 16 minutes. In other words, this is going to be whatever the radius of that circle is at the end of 16 minutes. This is what the radius was at 2 minutes. So it's the difference in the radiuses based on time. All right. A nice round number to stop on. We won't forget that we got through 10. Okay, good. Especially when I look at 11. 11 is just a graphing type problem. All right. Zach, I will talk to you next time. Are you staying in Arizona for the holidays, or are you coming back to Colorado?
I'm coming up there until Sunday.
Oh, well, good. We're supposed to have nice weather the whole week. In fact, on Thanksgiving, it's supposed to be 70 degrees, which I'm extremely thankful for because I got to drive down to Colorado Springs. It's always nice to not have to go through a snowstorm. I hope your flight is not too miserable. It's not the best time of year to have to fly.
Yeah.
You'll get through it. I will talk to you next time, whenever that shall be.
Okay.
All right, Zach. Happy Thanksgiving.
You too. Thank you.